Di sinilah universiti yang mengilhamkan masa depan. Masa depan generasi muda. Masa depan cara hidup kita. Masa depan negara ini. Dan masa depan bermula dengan mencipta pelbagai penerokaan. Masa depan bermula di sini, sekarang, di mana segala kemungkinan tiada batasan.
Okey, Syazwan ada? Boleh dengar tak, Okey, Syazwan?
Boleh, loud and clear.
Saya ada call Saya ada call, boleh akak je, cakap sikit.
Oh, ada. Sebab saya pakai web punya application kan.
Oh, ya ke? Tak apa.
Sorry.
So hari ni bagi lecture berkenaan dengan food design.
Geotechnical design practice. Is it okay if I share my
Boleh.
slides? Muka depan dia.
Assalamualaikum.
Waalaikumsalam.
Assalamualaikum.
Waalaikumsalam.
I hope everybody can see my cover page. I mean the first slide.
Nampak?
Yes, Dr. General Geotechnical.
Yeah. Perhaps I just turn this one down and wait for others.
Okay, Assalamualaikum dan selamat petang semua. Semua boleh dengar?
Dengar, Doktor.
Okay.
Dengar, Doktor.
Hari ini kita untuk subjek KEJURUTERAAN kita akan ada penceramah jemputan pada hari ini yang bernama Dr. Muhammad Syazwan Muhammad Rahim. Beliau merupakan Associate Geotechnical Engineer daripada syarikat Mega Consult Sdn Bhd. So hari ini dia akan menyampaikan talk about general geotechnical practice. Okay. So tanpa melengahkan masa lagi, mungkin Dr. Syazwan boleh memperkenalkan diri dahulu dan terus mulakanlah talk beliau.
Sure. Boleh dengar suara?
Ya,
Boleh, Doktor.
Boleh.
Okay. Alright. So nama saya Dr. Muhammad Syazwan Mat Rahim, as what being introduced by your lecturer just now, Dr. Reza. Okay, and as for today's, my obligation, my responsibility is to provide this general geotechnical practice lectures to all of you, because I believe this for your integrated design project punya course kan?
Yes.
Yeah, good. Okay. One more thing. For this lecture, I would like to have, I'll be asking several questions, and for those who can answer my question, please do so, because I would like this conversation to be in two-way kind of conversation. Kalau seorang je nanti kan tak sampai nanti. Okay? Tak dengar okay from anybody.
Okay, Doktor.
Alright. Okay, and for your information as well, I was before one of senior lecturer untuk FKB dekat UKM, but currently I'm working in industry lah. So bear with me lah if this lecture is gonna be like a lecture instead of a talk. Okay. All right. So first of all, okay. Before we get into detail about geotechnical design practice, the general stuff that geotechnical engineer would do lah, in a construction projects. Okay, first of all, you need to know the differences between these disciplines that involve with building construction. And as you can see dekat dekat gambar tu, I hope everybody knows that dwelling units or building can be differentiated into two categories, which is superstructure component, as well as substructure. And the reason why I differentiated this, because under geotechnical engineering, geotechnical engineer is responsible for the substructure, whether it's a retaining structures, whether it's a temporary, anything that relates to soil lah. And obviously foundation system lah. That's one of the main obligation or main responsibility for geotechnical engineer. Okay, so I think I don't need to explain this further, because these are just the disciplines, the people, the personnel that you would need to have in your construction projects lah. As for land surveyor, before you start anything, you would need the survey information. So land surveyor would do it. But I understand under civil engineering punya course, you guys been taught about land survey as well. Siap ada kemuku kalau tak silap saya. But I mean basically when you enter construction, these things will be catered by land surveyor lah. But as a civil engineer, you would need to understand how the survey drawings, the survey maps and such, GIS data, all this information to be utilized in your design. And then of course structure pun kita ada structural engineer, drainage, the infrastructure engineer will responsible for drainage design, pavement, as what you've learned from Dr. Easy, etc. All those memang basically ada dia punya specialized. It depends on the project itself lah. If the project is too big, then probably you would need to have this transport specialist as well. But if it's just rumah kedai 2 tingkat ke, I'm sorry, is there any overseas students in this class? I mean in this session?
Yes.
Oh, okay. So I shouldn't be speaking Malay then. Am I right? Or you guys already competent enough to understand Malay? Excuse me, foreign students? Hello?
Yes, doctor.
Yeah. Can you understand Malay? Or is it
Not
just poorly English?
Not well. Understand Malay.
Okay, that's the case. I'll try to maintain to speak in English.
Doctor,
for the whole session.
if you explain to English, it is better for all.
Okay, that will be good. Thanks very much.
You are welcome.
Yeah, I wasn't aware about that. Okay, I believe so. Pretty much so far you've understand the stuff that I've explained just now in construction projects. You will need multidisciplinary involvement in it, not just civil engineer, not just a geotechnical engineer. And coming to point number 5, now is the geotechnical design. So this is what a geotechnical engineer, I mean all these are under geotechnical engineers responsibility. They are the one who's going to design the substructure, the slope, if there's any surface cutting within your site area, and deep excavation if it requires deep basement, multi-level basement underneath. Then you would need to have a geotechnical engineer to design the retaining structures that is suitable for your underground underground basement. Okay, and additional, of course, we've got our friend from architectural department as well as M&E, in order to you pretty much understand architect aesthetically pleasing, and as for M&E, to light it up, light up the buildings pretty much. Okay, now I'm coming to the outline of today's lecture. So basically this lecture, hopefully we can finish up by 2 hours. Otherwise, yeah, we'll see. I think I can just cut off a bit at the final part of my lecture. But somehow I'm going to start with part 1. Okay, as a geotechnical engineer, you would need to know how to plan your subsurface investigation. This is important because you just imagine for experimental, I mean for a scientist, for him to design something, to come up with some solution, he needs to understand the solution itself. If it's a chemical substance, then he needs to understand the characteristic of the chemical substance. But now, as for geotechnical engineer, the same principle will be applied as well. However, for this case, it would relate to soil. So you would need to carry out your SI, your subsurface investigation, get as many as possible information. You can carry out field tests at site, as well as retrieving several soil samples and bring it to the lab for your laboratory tests. And all these tests are basically to determine, for you to come out with proper numerical properties, soil properties, so that numerical properties would represent the strength as well as the hydrological ability of that particular layer. Okay, so SI is very important. Is one of the main thing, most important thing as that a geotechnical engineer needs to understand. And then we'll moving on to part 2. Under this part, this section, I will explain a little bit, not too deep on foundation system, because I understand that for most of you guys, you will be quite bored with this, with the design, with geotechnical design, because there are too many formulas, equations that you need to remember. But trust me, after you go through for this part 2, I hope you will pretty much know how to handle all this equation. I mean, which one is to choose? I mean, which is related to your site, to your project site. And hopefully we could proceed with this quick quiz. Yeah. So I hope everybody will be will be until the end. Okay, and then part 3, I will discuss a bit on the concept and application for both bearing capacity and settlement estimation. And part 4, of course, this is one of the geotechnical concerns, because it, I believe for your site, for your IDP project site, you have been given a location. Am I right?
Yes.
Okay. So what you need to do is you need to choose the right platform height, that considering all these hydrological flooding all those criteria. I hope you know what's the purpose of having that design platform to be set. Okay, but since you have your design platform, and we understood, all of us understood that for natural morphology of an area, it will be very uncertain, very undulating. It depends at site. If it's a flat land, then you got lucky, because the platform level would be pretty much similar. But if your site is at the hilly side, then you will have a difference in level. So you need to do some cut and fill. And for those cut and fill, definitely there are only two options that you can apply. For this split level difference, it's either having a vertical retaining structures or a slope, and both of these are required to be assessed under those geotechnical assessment criteria that I've said that we mentioned in the textbook, like bearing capacity, settlement estimation, and as for slopes, you need to understand the stability, what FOS basically represents, and such. And as for point number 2 under part 4, advanced slope stability analysis, this would be an additional. I hope we could reach this by by 5 p.m. because otherwise we need to lengthen this session a bit. But this would be good for your understanding, especially some of you decided to proceed with their tertiary qualification, like doing master or something. Okay, so everybody's still with me at the moment?
Yes, doctor.
Yes, doctor. All right, good. Okay, so planning of subsurface investigation. Okay, so this pretty much as what you can see, this flow chart is basically showing how this SI soil investigation works, basically influence the overall of your assessment as well as soil interpretation. So as you can see, once you're done, can you see my cursor on the screen?
Yes.
Okay, so you can see once you're done your SI, you will obtain your soil properties, and this is the start where you're going to do your ground characteristic, and then in order to categorize your ground characteristic, which is soil layering, subsoil profiling, all these you need to determine the mass properties. And then from there, for ground behavior, in order for you to check what's the ground behavior once you apply your condition, let's say you're going to have a double-story houses on top with point load of 1000 kPa to the ground. So how are you going to design? I mean, of course, you need to design foundation, but how does this ground will behave right after you have this one? Sorry?
Sorry for cut you. Just I have one question.
Okay.
The quiz, it will be today?
Sorry?
The quiz.
The quiz.
It will be
We haven't
today?
reached there yet. Yeah, we haven't reached the quiz yet. So just bear with me. Or do you have somewhere to go?
No, with you, Doctor. But I ask you just for today, quiz. It will be for today.
Yeah. Your only quiz.
Because Doctor, at the end of the lecture, we have Jum'ah prayer today, Doctor.
Oh, where are you at? Oh, you are at the okay. You are in your hometown, is it?
Yeah, in Kuwait.
All right. Okay, yeah, just let us know. I mean, it's okay, no worries. I mean, it's just a quiz that I want to share with you guys, and I hope you will gain something for it. But it doesn't, it wouldn't be graded. So no worries. If you need to leave for Friday prayers, yeah, by all means.
Thank you very much, Doctor.
Thank you.
All right, so coming back to this, as I said, if you want to check your ground behavior, then these are the theoretical soil and rock mechanics you need to obey in order to check the behavior of your ground. And then from there, you can check the engineering performance, like if you are designing a pile, how does it perform, and all such things. So all these can be monitored with instrumentation that be installed at site. So all this would as you can see, is highly dependent to soil investigation work. So as if you decide, let's say once you finish your degree, you decide to become a geotechnical engineer, please make sure that yourself is aware about SI. Okay, these are just the definition. Okay, basically SI aims to identify the layers of deposits that underline the proposed structures and their physical characteristics. So basically SI is to be carried out in order to understand your subsoil profiling. And in construction projects, it depends on the budget, on the size of your projects, but normally I mean, if you ask me as a geotechnical engineer, I would suggest to carry out SI in 3 stages, because for, let's say it's just imagine a greenfield building, a greenfield project. Okay, meaning a land without anything in rural area, and you want to build an apartment on top of it. So before you can come out with your detailed structural design, normally in construction projects, they will start it off with preliminary design. And under this preliminary design, conceptual design drawings must be submitted to the clients. And basically, it's just in a short time, probably a month or two, for you to come up with the conceptual design. So you can't propose a full SI scheme for your site, because otherwise it will take time for you to get your information. So you can't meet up the deadline within this 1 month. So that's reason why it will be best to come up with a prelim SI where you define several points. Okay, it depends on depends on your site juga lah, because it depends. I used to do the electrified double track projects from Ipoh to Padang Besar, and basically we were having SI along the route from Ipoh to Butterworth. So you can imagine how the designer basically plan their SI along this proposed route. So that's what I'm saying. For prelim, since the name is prelim, so you can just propose several in order to pretty much understand the stratigraphy of the site. You come up with your prelim design, conceptual design, and then once you're going to proceed with your detailed design stage, then this comes the detailed SI, where you literally define your SI at the particular points where structures will be placed on top. Okay, so and of course during construction, in construction industry, you need to understand that nothing is certain. Sometimes you would have some sort like utilities or whatever's underneath structure that you didn't took account when you presented when you did your detailed design. So all these uncertain situation, it would be best if it's a major and highly related to ground structures. Then it would be best to propose SI during construction as well. So these are the normally carried out soil investigation works for a particular project. Okay, so all this I can just skip, because those are the details that I've explained just now. Okay, the reason why I'm stopping here, because I just want all of you to note that that as an engineer, you need to always remember that the majority of the unforeseen costs is associated with construction in geotechnical nature. Reason why? Because if you are a civil engineer, if you are a structural engineer, you just design your structure in accordance to BS, to whatever codes that you are referring to, either BS or Eurocode. But whatever happened to the building, if there's cracking or major cracks that's visible on your structures, then it is not normally when you do your geoforensic assessment, you would aware that mostly it is related to geotechnical structures that been designed underneath. So that's reason why I'm I hope you guys for those who intended to become a geotechnical engineer, please make sure please understand that mostly all these unforeseen costs, additional costs for constructions, not just costs but also risk. You need to remember risk as well. All these risks and additional costs are highly related to geotechnical structures. So a proper planning of SI is very essential. It's very imperative. Okay, so prior to the planning, the information. Okay, these are the prerequisites for SI. Okay, first, before you want to plan your SI, You need to understand the type of structure that you want to build on top of it. And then next point will be the topography of the area. Is it at hilly side? Does it have a depression somewhere, or is it a rolling terrain or flat terrain? I mean, you decide based on your studies on topography of the site. And last, this is quite important as well, because of course for a new site you wouldn't have any soil investigation work have been carried out at that particular site. However, it would be best as a geotechnical engineer to seek for this available subsoil information for whether it's at adjacent area, or perhaps the geological information of the site from the authorities. What I'm trying to say is that as a geotechnical, before you come out with your planning, please make sure you literally understand your site. Okay, whether there's information or not, you need to seek for that before you can pretty much certain with your planning on soil investigation works. Okay, so moving on. So in the industry, these are pretty much the rule of thumb that we not really all adhere to it because yeah, it depends. That's the best thing about geotechnical engineering. It would need the designer's judgment in their design, as opposed to structural. Okay, as you can just imagine, for a structural design, for any structure, if you follow your code accordingly, you will get the design of your structure. But as for geotechnical engineering, you not only need to have to understand the characteristic of the soil, but also there's pretty much a proper procedure for geotechnical engineering. Like yeah, it's not similar to structural. But yeah, but of course structure have its own challenges lah. But as for geotechnical engineering, judgment is very important. So that's reason why you can, all this expertise has come out with this kind of guideline for us to for new geotechnical engineer to specify their SI scheme. All right, so I can just skip this. All right, selection of exploration method. Okay, so on your screen you can see the table that shows different type of soil investigation works, soil investigation method. BH represents the borehole, MP Macintosh probe, CPT cone penetration test, TP will be trial pit, and HA hand auger, and GS is geophysical survey. All this has its advantages and disadvantages. And like I said, it's completely related to your site. So if your site is hilly, then probably borehole is the most appropriate soil investigation method to be carried out at site. However, if your site is actually located at soft soil deposit area, which has a very thick compressible soil deposit, then this probably you could apply CPT instead of borehole. So what I'm trying to highlight here is that before you can come up with your soil investigation planning, you would need to understand what are these methodologies are. You need to understand what borehole can provide you. What kind of information can you get from borehole? What kind of information that you can get from Macintosh probe, and so on and so forth. So this table is pretty much like a guideline. So I hope I'm not quite sure whether these slides will be shared with you guys or not, but definitely I will pass it on to Dr. Aizat. But yeah, once you have a look again at this table, please have a study. So especially for those who's in charge on geotechnical component of your project. So please have a look again on this table. So far everybody's okay? Semua faham ya? Okay, Doktor.
Okey, Doktor.
Faham, Doktor?
Alright, tak ada siapa tidur lagi?
Tak ada, Doktor.
Bagus, ada juga yang jawab. Aku ingatkan semua senyap je soalan tu. Alright, okay. Alright, now moving on, the selection of exploration method. Okay, as you can see, I'm spoon feeding you guys. I believe you guys can get a lot more information from what I'm showing you on the screen because, yalah, korang, I mean, nowadays, I believe you guys is more computer literate as compared to myself, especially with all those Google and stuff. So please check one by one what kind of exploration, but pretty much if you are based, if your only resources is just on just my slides on SI, so you can see that borehole, you would have a drilling, you would the site, the contractor would need to have this drilling rig as well as steel casing, and the information, the output that will be provided based from this all this procedure will come in a log kind of document. We call this bore log. All right, and this bore log, please have a look. I believe some of you might have this bore log as well. I mean, don't just glance through it. Go and check one by one all these details. What does it represent? If you do that, then you pretty much understand what borehole is all about. Yeah, the methodology, all the information about borehole. And then Macintosh probe is pretty much a handheld equipment. 2 personnel is required to carry out one Macintosh probe point at site. The way how they do it, the first person would need to hold the pole while the other one would lift up the hammer, which plays on top of it. And all blow counts, once it's reached 0.3 meter, it will be recorded. And those MP points, the next process will be the information that will be provided to geotechnical engineer lah. So please make sure I understand about Macintosh probe as well. And then over here, over here it's the cone penetration test. It's actually a continuous testing where you are extending probe with this cone tip. With this cone at the tip of your rod, and then you're going to push. This machine will be used to push this rod into the soil. Okay, and the termination is when this rod encountered hard layer within its length lah. All right, so these are sampling methods. Okay, if you go through borehole methodology, you will discover that borehole is the only SI methodology that can provide you with soil sample. And I believe most of you guys have done your first year course. Am I right?
Yes, Doctor.
Okay, could you please tell me what's the name of that module? Excuse me? Could somebody please tell me the name of that first module? The one that you did PSD, particle size distributions, LL, liquid limit test, Atterberg limit, those kind of things. So what's the name of the module? Wah, ramai tidur ni dalam ni. Hello?
Sorry, Doctor. Module or subject?
Subjek modul sama. Okay, tak apa. Okay, subjek. Okay.
Geoteknik.
Sorry?
Geoteknik. Subjek
Geoteknik je.
I think
Wah, ini you guys in your 4th year, is it?
Yes, Doktor.
Final year. Oh, dah first year, second year dah lupa lah. Hello? Come on, guys. I mean, what was your first geotechnical module? Itu je saya tanya. Saya bukannya nak tanya in detail teori ke apa ni. Right, we are running out of time.
I think soil mechanic.
Soil mechanic. Okay. Alright. If that's if that's the name of it, betul atau tidak saya pun tak sure sebab I left UKM 2017. I taught that module once, but I can't remember the name. But okay, soil mechanic. So what I'm trying to say, all those testing that you carried out in your laboratory tu kan, buat PhD, buat apa dia panggil, macam yelah dah macam buat kek lah kan, buat sieving, all those stuff. From borehole methodologies that you will get your samples in order for you to carry out those kind of lab testing. So please remember that. Okay. Alright, so far that's pretty much the details on SI. Ada apa-apa? Is there any questions?
Tak ada.
Are you sure tak ada? I mean, please, you guys are 4th year, so I believe you will be a bit lively. This is not a compulsory lecture. I mean, it's not like your normal lecture under any module or subjects. This is just, I mean, a lecture for you guys to understand how you can do your project. So if you don't ask me question now, I don't think that you will be able to fully understand what I'm saying. Damn, senyap terus. Hello? Or should I pick up a name instead? Hello? Oh, Dr. Aizat ada. Okay. Hello? Please, anybody? Please respond.
Yes, Doctor.
Okay, so Abid, okay, do you have any question? Please ask me any questions.
Okay.
Help out your friend because every question being asked related to what to SI lah. It will be a good information for you to proceed with your project.
Okay, so I have one question. Before we construct a abutment, right?
Okay.
So we still need the soil investigation, right?
Okay. Of course.
So
yeah.
can I know the like basic process for the to build a returning wall first and abutment, and maybe a bore pipe.
Oh, okay. Alright. Okay. Jangan ni don't mute yourself. Please stay unmute. Okay. Alright, that's a good question. So your task is to design abutment.
Alright.
Okay. So abutment, you understand, it will be designed by structural.
Yes.
Okay, so it doesn't have any relation to geotechnical. Betul tak?
Betul.
Okay, so untuk tampung to resist this abutment on top of the ground, underneath kena what would we need underneath this abutment?
Kena ada foundation lah kan?
Good. Okay. So foundation, I believe you've been to many sites in Malaysia. You've at least seen once in your lifetime piling punya rig tu. Yang driving ketang dalam TV pun banyak. Betul tak?
Betul.
Okay, so those are the equipments for you to design your foundation. So coming back to your questions, abutment, I cannot explain more about abutment because that one is under structural. But of course, related to geotechnical, we need to design this foundation. So sekarang you punya site kat mana?
Contoh dia macam dia ada orang kata tu river lah.
Okay. So alright lah, whatever lah, regardless anywhere your site is.
Okay.
Okay, for you to design your pile, you need to understand your location. Betul tak? The the ground underneath this abutment. Betul? Betul tak? It's a question to you. Betul. Why? Why? I'm asking you why. Because kau nak design, because you are designing the foundation. You need to determine what size of foundation. Is it a bow pile? Is it a big pile or small pile? Kayu ke apa ke? Right. So for you to design that, you will need to understand the soil underneath lah.
Betul.
Alright. So coming back to your first questions, you were asking me about which one, what is the procedure for you to do all this. So now you can, I hope you can answer it. What's the first procedure?
Saya rasa first soil investigation.
Sebab apa? Sekejap. Okay, that's correct. Soil investigation. Why is it important?
Because we need to know the behavior of the soil, the its characteristic, soil punya dia punya bearing capacity. So
okay, that's the thing. That's the normal thing that most of fresh grad and undergraduate confused about geotechnical engineering. They thought this ground behavior, bearing capacity, the settlement, all these are SI. Bukan. Those are your assessment, geotechnical assessments. When we talk about SI, kita bercakap the characteristic of the soil. You need to know how many % of gravel in it. Kau kena buat yang kau kena ni lah, ayak tepung lah dekat dalam lab. Betul?
Faham.
Kau buat sieving kan? Sieve analysis, korang buat mengayak semua kan? So that's why I'm saying you need to understand your stratigraphy, and your stratigraphy can be determined, can be characterized if you already obtain your SI, your information. So your test, all those tests that you carried out, minta you buat you punya sieving, you buatnya at the berg limits, you understand okay, soil at 3 meter, at the berg limits dia, the liquid limit is probably 70%. Okay, and then you refer, okay, 70% what kind of soil. Lepas tu from there you understand lah, basically from SI information, that's when you come up with your soil characterization. You characterize your soil, and then once all this characterized, then you proceed with your geotechnical assessment, which is bearing capacity, your settlement, your foundation design. So now you understand the process. Bila you cakap when you mention about those bearing capacity, I mean those are correct, but partially correct, because the first point that you were asking mengenai procedure awal-awal tadi was about procedure, which one to start first. So SI, because of what? Because from SI I can get information which I can characterize my site. I characterize meaning I understand lah how many layers underneath, jenis tanah macam mana, kuat ke lembut ke. Bila dah tahu tu, then you can proceed with your foundation design, because you are constructing a bridge abutment on top.
Okay.
Alright. So okay, thanks for the questions.
Alright, thank you, Doctor.
Alright. So okay, now I think we need to just jump into foundation systems. Okay.
Doctor?
Yep.
Doctor, I just want to ask one question.
Sekarang banyak questions. Tadi orang tanya tak seorang sengap kan. Please guys, I mean all of you. Sorry, hold on. All of you are in your 4th year. So I believe you must to speak up. This is the time. I mean you understand the current situation. Bila you grad nanti macam mana. Very highly competitive. So please speak up. I'm not giving you a lecture, but I'm sharing my experience and knowledge to you now. So if you don't grab it, it's your loss lah, not mine. So please speak up. So back to your questions. Apa tadi?
Okay, regarding to our particular project, those tests to find the characteristics of the soil, the behavior of the soil, such as seep analysis, proto compaction, consolidation, those result for our particular project. How we gonna get the data? Do we gonna go to the site and then do all those tests, or are we gonna just gonna get the data from our lecturer?
Okay, okay, I was part of IDP juga before this, and in fact, I also did my IDP during my undergraduate lah. So it's pretty much similar. Okay, coming back to your questions, if you do have money, you can carry out your own SI. That's one thing. But kalau tak ada, alright, this is the time that you need to catch any potential, any geotechnical engineers or any friends lah in the industry that you know, retrieve some information. And after all, this IDP is not, I mean, all of you must know that all these projects that you're creating for this IDP is not going to be realized at site unless it's something superb lah. Betul? Semua senyap pun, tak puas hati kan? Okay, but that's what I'm trying to say. I mean, for now, for this time being, as long as you understand the procedure, that will be good enough. So just get whatever information that is that you think logically to your side lah. Sebab I believe most of your projects, you already recognize your location. So make sure you understand your topography, dia hilly side ke, dia tepi sawah ke, kat mana ke. So bila you dapat SI information nanti, takkanlah you tak tahu tepi sawah, takkanlah apa tanah keras kan, tanah pun mesti clay, lembut benda. Sekali kalau kau pakai SI yang atas gunung punya, do you get my point?
Yes, I get it.
So that's what I'm saying. Just get whatever information that you could obtain from outside. And yeah, after all, it's your project. So to answer your question whether it should be obtained from your lecturer, I don't know specifically, but if you ask me, I would disagree on that procedure. You guys in your fourth year, you should know, you should be able to get somewhere lah. But that's the thing, don't do it without reading. So you need to read dulu, make sure you understand what you're asking for. Don't just simply ask for information without understanding what the information is actually for. Okay?
Okay, Doktor.
Yeah. Menjawab ke tak tadi tu?
No, actually, for our particular site, is there already have the site investigation report, or that one I want to ask, because we don't know where we can get those data, those soil investigation data.
Sekejap, apa Iqbal? Just now you said, Iqbal lah. Is your name apa? Okay, sorry, but apa you mentioned you already got your SI report. Betul tak? Can you please stay unmute? Okay, Azam. Alright.
Yes.
You said that you've got your SI report.
No. We didn't get it. Maybe not yet.
Okay.
I think.
Alright. Okay, that one I believe you would need to discuss with your lecturers lah. Tapi apa, like I said, my advice, since we've gone through this part 1, and I hope you understand whatever that I've explained during my part 1 punya session. So apa, you dah tahu apa yang saya explain, you kena check topografi site you dulu, dia tepi laut ke, dia atas gunung ke, macam mana, and then kalau lah let's say you dah dapat SI report, you counter check, okay SI report ni lebih kurang tak, kalau atas gunung kita tahu dia memang rocky, so apa memang tanah-tanah keras lah. So kalau information borehole tu dalam SI tu, dalam SI report tu you baca, semua menunjukkan tanah-tanah lembut, okay, then it wouldn't be realistic lah. But still, I don't know whether you can still proceed or whatever. But my main point is that please understand the information that you would require. Don't just know that you would require SI report. Okay, I've got it. What to do next? No, that's not how an engineer should do. I mean, if they want to get SI, okay, they must understand what SI is pretty much about. What does it say? What boreholes, what bore log indicates in its every numbers in the bore log, what does it represent? So that's the point that I'm trying to highlight lah in this session. All right, so Azam, I hope I've answered your questions. So okay, all right, so try to move on to second part, which is foundation system. Foundation system is quite pretty much straightforward because okay, this is something that you need to understand. Okay, all those pilings, strip footing, whatever type of foundation structures that you apply, that you design at site, those are just foundation. Those are not basically a system. So if you are talking about system, it must be your piling. Let's say you are proposing or you're designing a piling. This piling must have this similar counter reaction with the soil. So that's reason why I told you per soil information is very important. You can design your pile whatever size you want to, but without understanding your site, it will be most likely over budget cost. I mean, there will be a lot of unnecessary cost lah in your construction, in your construction projects, in your projects. So make sure you understand your soil, because as for the foundation, the system that we want to design, it's not the foundation that we want to design. Saya boleh saja, I can just simply, if I want to build a house on a flat land, I could just propose to have 0.5 meter, 0.5 diameter pile, span pile to be penetrated at ground, at the footprint of my home. That would be it. Yeah, I can just as simply as that. I can just do that simply. But the actual thing, as a geotechnical engineer, it's not the foundation that you are proposing or you are designing, but the system. So you need to understand the mechanism that actually happening when you are designing your foundations, your foundation. Okay, so foundation, this system can be divided into two types. One is shallow foundation, deep foundation. Okay, shallow foundation, all those strip footing, pad footing, and all this, basically when you are designing shallow foundation, is just the size of the foundation that you need to determine. While for geotechnical criteria, the main thing that you need to check is the bearing ability, the bearing capacity of your foundation. Let's say you are having a square 3x3 square foundation, then you need to check whether with this type of soil that is existed at site, would it be able to bear the load imposed on this foundation. So that's reason why you need to understand the soil. Okay, on the other hand, if the structure is too big, then of course deep foundation is more appropriate. And under deep foundation, it can be divided into two: displacement pile and replacement pile. Okay, and displacement pile, since we are displacing the soil masuk ke dalam, so you can just imagine that it is something, it's a procedure that you are poking or penetrating the pile into the ground. Okay, this is completely opposite to the replacement pile procedure. Replacement, you dig a hole, you make a borehole, you insert your reinforcement. Okay, you are using whatever lah, T steel or Y steel or whatever, but you design your reinforcement, and then you're gonna replace this hole that you already extracted beforehand. You're gonna refill it with concrete. So that's, I mean, those kind of foundation, those kind of piling, we call it either micro pile if it's lesser than 300 mm size, diameter size. But if it's larger than 300 mm diameter size, it will be called board pile. Okay, so displacement, whatever that you are listening, you're experiencing at site, you heard those hammering, pile hammering procedure executed at site, then those are displacement pile, which is either precast pile, RC or span pile. And yeah, just these small notes underneath. Okay, basically all this under deep foundation. Okay, since yeah, even though there are differences between displacement and replacement methodologies, but still to calculate the geotechnical capacity of your pile, you need to understand what is skin friction and base resistance, because these are the two components that acting on your soil, on your pile surface within the soil layer. So that's reason why, again, you need to understand your soil so that you will be able to understand how much the skin friction component will contribute to the geotechnical resistance and how many percentage provided by base, which is the tip of your pile. Okay, so these are just the further details on displacement pile. I can just keep this. If you guys want to understand more, please have a have a browse through of these slides later. But yeah, these are the displacement pile that I've mentioned just now. Besides RC, the steel pile, also because we can categorize it under displacement pile. Same goes with bakau pile and tubular steel pile. Cuma sekarang in Malaysia, bakau pile dah tak boleh rasanya. Kalau zaman dulu, normally engineer will come out with bakau pile solution for this box culvert, small structures lah. Like box culvert ke, kalau ada U-shaped drain ke apa, all this, as a geotechnical engineer, you kena check what's the bearing capacity of the contacting soil. But of course, if the soil cannot resist this structure, then the structure must be supported by pile. And during those days, bakau pile was allowed to be used for foundation. Alright, so this is the replacement pile. As you can see, the procedure is pretty much what similar to what I've described before earlier. Okay, you make a hole, you insert your foundation, and then you pour in your concrete. Okay, these are some of the pictures. I believe you can Google this up, and you will get a better picture as compared to what I'm showing you on the screen. All right, so now is the load resistant mechanism. Just now I mentioned that when it comes to deep foundation, a geotechnical engineer must be able to understand what the definition of skin friction as well as base resistance. I mean, because pretty much you understand, we insert something into the soil, you will have resistance, which is the friction on its surface, as well as the resistance at tip. So if you are having a hollow type of pile, you wouldn't get any base resistance lah. So pretty much for hollow pile, the concept is friction pile. I mean, they are also being called as friction pile because no component of base resistance exists when the pile being installed at site. Okay, however, on this screen, as you can see, this friction and end bearing and base resistance is also dependent to the type of the soil. So if you are having a loose soil on top and hard strata underneath, then you mainly you wouldn't get a reasonable contribution from skin friction because it's a loose soil. However, underneath is hard stratum. Then of course this system that you're applying, regardless what any type of pile that you're proposing, this system only allows end bearing, which is base resistance for your foundation. And as for B, there's no hard stratum, similar to hollow pile. You will get your resistance only comes from skin friction. Nothing comes from base resistance. And there's also a condition where they combine both end bearing and friction pile. And as for D, this pretty much a procedure for ground treatment, where you want to compact the soft soil, the compressible soil at site, in order to improvise its bearing capacity. All right, so this is the I forgot about this negative skin friction. Okay, so this is another reason why soil characterization, soil understanding is very important before you can proceed with your foundation design. Because if, let's say, if your site is having a very thick soft deposit, compressible material, then for this, within this compressible material layer, you wouldn't get any uplift resistance from your skin friction, because of all this, because of if you go through your foundation engineering textbook, open up consolidation, and then you would understand that for soft soil, if you impose load on soft soil, for instance clay, it will induce consolidation settlement, and consolidation settlement is actually it's actually progress with time. So for this particular layer, this soft soil layer, you wouldn't get your uplift skin resistance. However, it will create a negative skin friction, meaning your pile will settle even more. Okay, so that's the importance of having to know your site better. Okay, so another thing about foundation system, okay, let's say if you are designing a jetty, you understand that those jetty will be anchored with will have vessels to be docked next to it, and there will be like a mooring and like a compress and tension force acting on your jetty. So all this will be overcome by your pile design. All right. So just imagine if you are on a jetty in Pulau Redang ke, in Pulau Perhentian ke, if you are walking on a jetty, when you tie up a boat on your jetty, it's not the deck, the slab that you are walking on top of it that actually helping resisting this pushing and pulling from the vessel or boat. It's actually the pile underneath. So that's reason why, as a geotechnical engineer, you need to be experienced enough to make any judgment. However, the best way I would suggest is it would be best if you could try to understand the basic concept of it. So once you understand the basic concept of it, you would realize that all this design that is being tasked to you is actually very important, and you literally need to understand the procedure. Otherwise, I don't know what's going to happen to your structure lah. So as an engineer, you need to make sure that you understand all these procedure. It's pretty much, it's pretty much straightforward. If you, I can give you an example. Let's say if you want to ride a bike, first thing that you need to do, you need to understand the size of the bike. the function of it, what those pedals actually for, what those handles actually for, what kind of material has it been made. Betul tak? So you need to understand your material before you do your design. So same goes with geotechnical engineering. In order to design something, to realize your design, you need to understand the soil. So all those information that you've obtained during your first year subject on geotechnical engineering, soil mechanics, kejuruteraan asas, whatever subjects related to geotechnical engineering awal-awal tu during your first two years tu, those are very fundamentals. So please, for those who's in charge on geotechnical design for this project, please revisit your those subjects lah. Okay. Alright, so coming back to the slide, this is one of the mechanism that would happen on your pile. So you need to design for it. Okay, and as for today's sections, for today's session, I hope I could get all of you understand at least how to select a pile, at least out of this after we complete with this lecture session today lah. Okay, so these are the three main components when you want to select a pile. First you need to understand the environmental or site factors. Okay, does it close to buildings, services, structures, slope, whatever lah. So that's reason why I told you need to literally understand your site. Check what's this topography and such. And then second, subsoil conditions. This when the SI comes in. Once you receive the SI, okay, you check what's the type, you characterize your soil, you get your soil strength and such, and all this information. Then you will be able to understand your subsoil condition. And then, but then you still need to consider the third criteria, which is type of structures that you want to build on top. Is it a minimal? Would it contribute to a minimal load or maximum load? So not maximum load, but substantial load. If it's substantial, then you can just straight away use deep foundation. Otherwise, if it's a small load, you can just start it off with shallow foundations. So these are the three main criteria that you would need before you select your pile. Okay, so this one is details on marine. Never mind, I'll just keep on this. It's just okay. This figure pretty much explains the reason why I highlighted many times about the importance of SI, because these are the possible condition that would happen at site if you don't literally scrutinize your soil information at site. You'll be having insufficient pile length. You'll be having your tape settling only at these localized sand denses. It's not literally rigid. And then you'll be having, if you don't literally understand your subsoil profile, the contractor will face a lot of losses because your pile might break at certain part and such, and all these other situations lah. So that's reason why please understand your subsoil profile. And then for pile shoe, okay, these are some of the pile shoes available. This pile shoe has different functions to it, but when it comes to theoretical, like I said, without regardless whatever pile shoe that you are adopting, for geotechnical assessment, the only thing that you need to concern about is the base resistance. So this pile shoe, I believe once you've come to the if you happen to get the chance to design a foundation, I believe you would go through these informations lah. All right, so this part installation tolerance, I'll just put this on in this slide. You can, all of you can just have a look through. Okay, pile depth estimation. All right, this one I don't want to describe in detail because okay, can somebody tell me which subject that actually explains about foundation pile depth estimation? About foundation design equation. Hello?
Okay, Doktor.
Yep.
Again, tak dengar.
Oh, tak dengar. Alright, which subject that actually provide you guys information tentang foundation design?
Foundation engineering by Dr. Aizat.
Foundation engineering. Okay, so I believe all of you must be familiar with the equation that I'm showing on the screen. Wah, senyap. Hello? Okay, Abdul Majid. Could you just answer my questions? Do you recognize this equation on the screen?
Actually, I don't think we have reached.
The QU, it is mean ultimate shear.
Ultimate?
Ultimate shear. The
shear?
QU. Yeah.
No, that Q doesn't represent shear.
Q all, sorry, Q all.
Q all, okay. Ultimate. All right, anybody else?
Doctor, I think our class didn't reach this topic yet. We just already have 2 class only.
Okay, for foundation.
Yes,
for foundation engineering.
Yes.
Okay. If that's the excuse, then yeah, I will accept that. But and okay, how would I describe this equation? Okay, just now, as what I've explained, when you design your deep foundation, these 2 main components that you would need to understand. One is the skin friction, and the second is base resistance. Okay, QU is the ultimate resistance, geotechnical resistance, or in other words, if you apply it on shallow foundation, QU is the ultimate bearing capacity. Okay. For shallow foundation, for street footing or for pad footing, your QU will depends on the equation that you adopted based on the type of soil encountered at site lah. However, for deep foundation, this QU is actually the bearing capacity that has been contributed by these 2 components. Okay, QS represents the site resistance, or in other words, skin frictions, and QP is the Q peak, which is QB. I think I need to change this to B. So it's actually a QB, which is base resistance, and Q all is the allowable bearing capacity. Okay. All right, before I move further, I just want to someone please explain to me what does he know does he know anything about factor of safety? What does it mean? But yeah, I think you guys have used this term even in structural, right?
Yes, Doctor.
Yes.
Okay, so can somebody please tell me what is the definition of factor of safety?
Factor of safety. I think we measure how much the percentage of the safety for that particular building.
Okay.
In term of 1 equal to 100%. So usually for the building, we need to we need to have more than one, because adequate is not enough. So we need to have more than one. Usually we have 2 or 3, the safety factor, which means 200% or 300% safe.
Okay, good. Just carry on. Tak apa, saya dengar. Yeah, I just want to know, what's your name?
Azam.
Azam, okay, that's good, Azam. Yes, apa? Okay, what was it? Apa soalan? Okay, factor of safety. Alright, yeah, exactly as what you said. Okay, guys, can you just imagine? Alright, if you are having a rope, okay, if you are having a rope, this rope, okay, this rope is to actually, macam mana lah, how would I explain to you guys? Okay, just imagine if you're flying a kite lah, sort of kite, okay, and you're flying a kite, and then you have this rope that actually connecting your kite to your hands, okay, when you are at the ground. So, okay, let's say if the weight of the kite is 1 kg, and your thread, your rope, the capacity, once you study about it and you understand, the capacity is equivalent to the weight of kite, which is 1 kilonewton lah. The pressure from the force from the produced by the kite is 1 kilonewton, and your rope is 1 kilonewton capacity. So would you think that the rope will break? Okay, do you guys Azam understand?
Yes,
you understand? Okay, if your rope is the resistance, the capacity is 1 kilonewton, and the force acting by produced by this kite is 1 kilonewton, so you have almost zero factor of safety, meaning you are actually using a rope which is the condition is highly possible to break anytime when there's an additional force acting on your kite. So
That's true.
all right, so in order to make sure that you won't lose your kite, you'll be having like a 2 or 3 layer lah of ropes that's going to hold your kite. So those are factor of safety. Okay, so you just imagine the reason why we are having this Q allowable is to have a reduced bearing capacity, so that whatever design load that you are acting on top, it must be lesser than this Q allowable. Faham? You get it?
Faham.
Alright, okay. How about the rest?
Clear, Dr. Clear.
Woi, marah seorang tu kan. Okay, so yeah, that's my point. That's the reason why I'm highlighting this FOS, because you guys will be using FOS for everything when it comes to design, in structure, in hydrology, in geotechnical, of course. And as you can see, for geotechnical, for skin friction, these are the standard factor of safety being set for any design in Malaysia. So your skin friction resistance must be divided by 2, while your base resistance, whatever base resistance that you calculated from your design, it must be divided into 3, and the summation of it would be your Q allowable, and this Q allowable represents the resistance, the system, the resistance of the system, of your foundation system, in order to prevent better support of your load on top lah. Alright, so these are the pile depth estimation. So I'm going to skip this because Azam tadi, I heard somebody mention to me that you haven't go through with this foundation design yet. So these are the additional information that you can use once you've learned about how to calculate the skin friction and base resistance. So I'll just keep all this pile depth estimation in rocks. So these are the equation that you could use when you are encountering those kind of formation. All right. So now comes the examples. So I'm showing you two examples that were designed by myself. First is Taman Seni. This is a building. Okay. Ramai tak yang tahu kat mana Colosseum? Colosseum, panggung wayang Colosseum in KL.
Tahu.
Okay, so it's opposite Kamda kan. So you tahu dekat sebelah Colosseum there's a site. Okay, sekarang ni currently being covered with with blue fences lah. Tapi dalam tu there's a proposal that the DBKL nak construct taman seni, which is sort of like kedai lah dekat dalam tu nanti. So it's gonna be a double story close to this Colosseum, which has been gazetted by the government as one of Malaysia historical building. Okay, so for these examples, as you can see, first you need to understand the land survey. So this is what I did. I made myself understand the topography, the condition of the site and such. Okay, so I've gathered all data from site, and from there I understand that the first 5 layers is pretty much very loose sand to very soft clay, and then underneath is firm clay, while beyond 10 meter underneath is mostly dense gravel with SPTN of 50, which is hard layer lah, in other words. Okay, so these are the prerequisite information before I can come up with my pile selection. As I said, we would need a structural layout, and these are the layout of the foundation, of the column points as well as foundation points lah, given by the structural engineer. So they will come up with all this and provide the forces acting on each point. So as a geotechnical engineer, you need to scrutinize this information. All right, so some of the 3D visual that you can see, this is Colosseum. Lepas tu Kamda across the road, and this is the site. This is what they plan to do lah. So as you can see, so I believe most of you guys have been to KL and must have encountered this area. All right, so for this Lanai Seni project, pile selection criteria. So what I did was, based on those 3 components, the 3 criterias, I've listed down the advantage as well as the disadvantage. Okay, as you can see, as for point for environmental or site surrounding or site area. Okay, first I discovered that this foundation is too close with adjacent building, which is one of historical building in Malaysia lah, has been gazetted by the government. So there is when you are constructing, if you are doing any construction activities with a certain distance to these historical buildings, there's a guideline that you need to obey, because the government is the reason why they gazette that building as a historical building, because they want to protect it. So in order to protect it, you don't want any external disturbance to be happening surrounding those surrounding that particular building. So they've come up with this guideline, and so for this Lanai Seni, for this proposed Lanai Seni, my pile selection must consider about the methodologies that needs to be adopted at site. So one of the point, like I said, it's too close to adjacent building, and it's located higher density area, meaning you can't bring big machines to the site. So you need to consider that in your piling selection. And of course, you don't want anything to happen to this historical building. So you need to avoid any vibration, because as an engineer you should know that vibration will induce disturbance to anything, not just human buildings, but even trees and such. So you need to consider that as well. And as for point number 2, subsoil condition, I understood that this site is located within Canny Hill and Limestone Formation. That's okay. Why I'm highlighting this Canny Hill and Limestone Formation? This comes to what I tried to enlighten all of you, that SI is very important. Understanding your subsoil profile at site is very important, because limestone formation, limestone cavity is, limestone formation, especially in KL, is very critical. You probably would encounter, if you dig a hole in KL, especially somewhere, yalah, dekat kawasan ni lah, Jalan Tunku Abdul Rahman ke, or towards KLCC, or even in Cochrane. Cochrane has a very ceras tu, Cochrane ceras. Underneath it is a very complex limestone formation. Problem dengan limestone formation is that you don't know where the cavity is. It can be everywhere. If I'm standing here at one point and I'm having another, if I'm having a hole at one point and then I'm getting another borehole which is probably about 2 or 3 meters away from that initial borehole, probably this stratigraphy would be different, even in that close proximity. So that's the problem if your site is located at limestone formation lah. Okay, so that's reason why I'm saying, before start your design, please understand your site, especially anything that is existed underground. Okay, and then my last point for my past selection criteria is the working load. 1400 kilonewton and 2500 kilonewton, and this must be included in my judgment as well. And as you can see down here in this green box, I've proposed several suggestions. However, the first one is the most appropriate lah, because micropile, as I've mentioned, it is a bore pile, replacement pile that is less than 300 mm diameter size. So you can imagine, if the smaller the size is, the smaller the rig will be. So you are having a site constraint. So this is very important. And why micropile? Why replacement pile? Because I don't want to have any vibration to exist during construction, because this would jeopardize the building next to it. So replacement pile is the most suitable, because you, like I said, the procedure, you make a hole, you are replacing the soil. You are not creating any vibration, because there's no hammering is to be conducted at site. And last, if you, in this, when you entered the industry, you would realize that even the without hammering, you can still penetrate displacement pile into the ground, and this by using this hydraulic injection pile injection rig lah. It's a huge machine. Bring to the site, it will hold a pile and push it down, and it will create no vibration at all. Okay. Oh, I forgot to share screen, post slideshow. All right, so next, my example will be Wakaf Baru. Okay, this is a road project located in Wakaf Baru, Kota Baru, currently being constructed. So the total length is about 15 kilometer. However, we are not to discuss the overall stretch of the road. We are just focusing on these three sections, which is the first one, Ariwal section. second one ram section, and the last bridge abutment. Okay, so these are the location of those three structures that I mentioned just now. So you are having two bridges. One is for the bridge over river, and another one is a rail track bridge. Okay. RE wall is located at the edge of the road, so meaning it's a vertical section, it's not a slope. Same goes with this part and that part as well. And there will be a ram. A ram ni apa yang it's an elevated road works actually. So in Wakaf Baru they'll be having this flyover lah. So this is the ram that we will be focusing on. Alright, so this is the soil profile. Okay, briefly, the red color means clay, clay soil. The brown one is silt, and the yellow one is sand. And if you focus on this on these tables, you would realize there's no hard layer. There's no SPTN 50. So it's pretty much soft soil, competent soil, soft soil, competent soil punya layering lah sampai ke bawah. Okay, so first structure, which is the RE wall section. So this is how RE wall looks like. RE wall is a retaining structure system with strip. So as you can see, I need to design the foundation system for this RE wall. All right, and based on those three components, I've discovered that one of the possibility failure that could happen under this condition. The condition is potential overturning failure. So basically, despite only designing the size and the length of the pile, I also need to consider the resistance of this pile, of this proposed pile, to resist this potential overturning failure. All right, so to carry out those kind of assessment, you will definitely need to use Plexis, finite element method punya software. Okay, let me just keep these two. Okay, this one is RAM. So my example here will explain how I select the type of foundation lah for this RAM. And the last one will be the foundation for the bridge abutment. Okay, so pile selection criteria. For RE wall, I've discovered no sensitive structure exists surrounding the area. So, from SI, I understand that there's no hard layer encountered at site. So basically, it's interbedded soft soil material. And then last, I need to consider is I need to check how this pile can resist due to this potential global stability failure. And then for second structures, which is the RAM section, I've discovered that there was no potential global stability failure could occur, and the rest pretty much similar to RE wall sections. So yeah, those are my concerns lah. You know, before I select my pile for each structure. Sorry?
What you mean by no potential global stability failure?
Okay.
Example.
All right. So if you look at here, okay, the foundation is basically to resist the RE wall. Okay, so that's the reason we are having some sort of like a pile raft underneath it. A pile that is connected by a slab, a huge slab on top of it. And since there's the length is not substantial, it's about 3 meter length. So there is a potential of overturning failure to happen at site. So as a geotechnical engineer, besides only having to know what is the size of your pile as well as the length, you also need to check the type of the proposed type of pile. Can it resist this stability failure? So you need to check that as well. However, as for the RAM sections, as you can see, it's connected. It's a single unit, so there's no potential overall stability failure. So as to select the type of pile as well as to design it, you don't need to consider this potential overturning failure lah for that case. You get it? All right. Okay, so coming back to this, point number 3, bridge. So as compared to RE wall section and RAM sections, bridge, you are having abutment for bridge on top, so definitely high working load. So you can imagine that your pile must be bigger than these two. And as you can see, it's located next to a rail track, as well as the other one is at the river bank. So you have a very limited spaces, and since it is in close proximity with KTMB punya line, KTMB punya line pun ada requirement if you want to do anything surrounding it. It wouldn't allow any vibration. Otherwise, the rail will be displaced and apa accidents could happen lah under KTMB. So as a contractor that is doing something adjacent to their site, they need to consider that guideline as well lah. And as for this case, no vibration is allowed. All right, so what kind of pile did I suggested? So for RE wall pile, I've proposed 400 mm diameter span pile. Okay, why didn't choose square pile? Because span pile, as you can see, this is a schematic of a span pile. It has a spiral reinforcement within it. So span pile has been designed to resist lateral load as well. Sebab tu, if you go to any jetty in Malaysia nowadays, if it's a new jetty, normally you will encounter a nice round shaped pile lah, and that is what they call it span pile. Sebab dia boleh resist, it can resist moment, force, additional force to it. So that's reason why for RE wall sections, span pile was selected. Fixed length because we don't have any hard stratum underneath. And why 400? Because 400 could provide the skin resistance as well, the adequate skin summation of skin resistance and base resistance. So meaning you get a nice Q allowable lah, that is lower than your load. Okay, so for RAM section, since there's no potential overturning, so we can propose a simple RC square pile to resist this compression, vertical compression. And fixed length has been set as well because we don't have any hard stratum, and working load is about 300. And if you go to structure for bridge abutment, 1.2 meter bore pile was proposed, and you can imagine how big would it be at site. 1.2 meter, there's going to be a huge machine to make a hole. And why bore pile was chosen? Because as I've said, I didn't want any vibration to happen at site, so replacement pile is the most suitable lah, which is replace, insert reinforcement, and then pour in your concrete. And this, due to this size, it can resist very high working load, structural load. All right, so those are the first first procedure, selecting a file, designing the file. When I say designing, you determine the adequate size as well as the length and such. But that's just the first part of file procedure lah, file construction procedure. Because once the contractor has done it at site, file tests must be carried out on those files. If not all, at least a certain 1 or 2% of the overall available file, available working file. And you in the industry, normally they would use they would have a preliminary file test and working file test. Working file test means during construction file testing. All right, so I'm not going to explain further about this. These are just type of file tests that you can carry out on your files in order to check whether your design is adequate to achieve the working load required. It's 28 days before a testing can be executed on that particular file. All right, so now comes the quiz. All right, can everybody see this screen?
Yes, doctor.
All right. Yeah, I think I would like to choose some of you to actually explain to me now, because it's a quiz, so it should be a discussion instead of a lecture. So who would I choose? Is there any volunteers? Hello?
Hello.
Okay, we got one volunteer. Siapa? Azam?
Okay, doctor.
All right, okay. Please stay unmute. Okay. All right. So just this one page. Next is the third part. I think we try to finish up before 5 lah. All right. So this is a project in Sarawak. Okay. Project ubah suai bangunan, upgrade, building upgrades for clinical research center in Sarawak, hospital in Sarawak. So what the client, which is Malaysian the government lah, what the government wants to do at this hospital Kuching Sarawak is that they want to construct a new building, a proposed location which is right next to building A and building B. So basically extension of hospital Kuching Sarawak lah. And this is the information that I've provided. As you can see, it has a very soft soil down to 3 meter with SPT N of 1, while beyond 4 meter, the stratigraphy will be bedrock sandstone with SPT N of 50, or in other words, hard layer. So based on these two information, could somebody except for Iwan Azam pun boleh juga, could somebody please tell me what kind of suitable foundation system can be adopted for this location?
How deep is it? 4 meter to bedrock. With
Yeah, it's a discussion, guys. Discussion. Just anybody who has idea what to think, just throw it out.
So because of the building nearest to the proposed location, so we want to avoid any vibration that can affect the building.
Okay.
So we can use hydraulic induced for the pile.
Okay.
Such as a deep pile, or we can use a replacement pile because the distance from the surface to the bedrock is not deep enough. You can use a shallow pile.
Oh, okay. Alright. Okay, shallow pile. Okay, that's good. Itu pun boleh juga. Yeah, habis ke or you want to add on slightly more?
I want my friend to add.
Okay. Kau suruh dia cakap sikit. And I want one of the ladies, please. Have some guts to discuss. Hello? Where's your friend? Semua senyap ni lah. Okay, tadi tu siapa? Abid eh?
Azam.
Azam. Okay, stay unmute Azam. Which one, can you point me which one is your friend?
All is my friend.
Yelah. I mean, the one that...
Afrina Nasir.
Okay.
Afrina Anwar.
Okay, Afrina Anwar. Can you turn on your mic, please? Oh, she's not at her desk. Alright, we are not going to wait longer. Come on. Apa? Afzan Nurjeha? I've got the first point from Azam. Okay, what he's saying, he's suggesting to have this replacement pile. Okay, that's good. And to avoid vibration. And he also mentioned, yeah, since it's shallow, so maybe we could propose shallow foundation. Okay, Afza, are you there? Siapa yang ada? Ladies? At least one of you? Hello?
But doctor, the depth to the bedrock is more than 3 meter, right? So because the shallow foundation normally less than 3 meter of the depth or the depth of the width of the footing. So if is it more than 4 meter, should we use the deep foundation?
There's no correct or wrong in as long as you understand that this particular quiz is all about is basically to select a pile. So as long as you understand what I've taught you just now, I've explained about the pile selection criteria, and you can adopt this on this discussion, on this quiz discussion, I'm more than okay. So it's not, yeah, I agree with you as well. So if it's more than 4.5, probably deep foundation. Is that what you're trying to say?
Yes, doctor.
So I agree. Now I just need suggestions, idea from somebody else. And I hope you will be a lady. Okay, somebody's leaving. Hello? Afrina tak ada. So, Bakir, are you there? Ahmad Bakir?
Yes, doctor.
Okay. Do you pretty much understand the intention of this quiz?
Yeah, doctor.
Okay. So what's the suitable foundation system that you think suitable for this case?
I can choose the shallow foundation.
Okay, and why is that?
I can choose the raft.
You can't choose the raft. Okay, yeah, I understand. You don't want to choose raft foundation. But why? There must be a reason.
Because the raft foundation can can resist the load.
Okay, that's a good point.
Yeah.
I think that answered what Azam was asking about shallow foundation. Okay, shallow. Yeah, initially he thought he could do shallow foundation, but
I prefer the raft foundation, shallow foundation under the raft foundation under the shallow. But I prefer the raft because the raft
so when you say
can
raft,
resist more load.
okay, when you say raft foundation, it's a slab
This
with
under the shallow.
Sorry?
This under the shallow foundation.
Under the shallow foundation,
Yeah,
a raft.
Yeah.
Okay. You are doing double works because you are having a raft foundation underneath, and above it you are placing shallow foundation. That's a bit weird. But my point is that I just want you. I mean, if you literally understand my point about this deep foundation, that it can be categorized into two types, which is displacement and replacement. You most probably will be able to answer this quiz lah. And okay, never mind. So since we are not getting enough participation from this class, so I'll just discuss what Azam has mentioned just now. Okay, yeah, it was good. You managed to tell me that the reason why you choose replacement because yeah, it's more than 4.5 meter. If you want to do normally shallow foundation, people would do it maximum 2 meter below the ground lah. If it's too deep, more than 2 meter, orang akan terus pakai deep foundation. And yeah, I'm impressed when you say that you chose replacement instead of displacement because you also concerned about the building A and building B. There will be patients in the building, so if you apply vibration, terkejut pakcik-pakcik dengan makcik-makcik kat dalam hospital. So replacement. However, you didn't tell me about the size. Yeah, about the ball pile. Is it a ball pile, big ball pile, or a small ball pile? And for that one, I will just explain to you the best suitable foundation system for this case is to have a micro pile because it's small. It only utilize a small rig to install this pile, and of course with this site constraint, the proposed location is very very small. It's doesn't have a suitable space on it, so definitely will be hard for contractor to bring their big machine. So micro pile is the best options for your proposed building extension. So that's our quiz. So we've got another 5 minutes, 5 to 10 minutes if I'm not mistaken. Yeah, another 5 minutes. So these are
Victor, can you share this slide note at Microsoft Team in the chat?
Yeah, I will let it. I will share it with Dr. Aizat, and we'll let him to share it with the rest of you guys. Is that okay?
Okay, Victor. Thank you.
So as for bearing capacity, this I hope you guys since you guys is still in your foundation engineering subjects module. So definitely under that subject you will encounter a lot about this bearing capacity and such lah. So, and in fact for this IDP project, like I said, all these geotechnical assessment, bearing capacity, settlement estimation, and retaining structures, all these geotechnical assessment. It's not the SI that we've talked about. It's not about foundation system. Foundation system is a design of your foundation or system. However, under part 3, all this is geotechnical assessment. So you've designed something, you need to consider what kind of geotechnical failure that could happen at site. So you need to carry out all this assessment in order to make sure that the component is satisfying lah. Is above what being set in the guideline. Alright, so bearing capacity, all this is pretty much something that you need to read. And let me just keep settlement estimation. Okay, I'll talk a bit about settlement estimation. Okay, for settlement is one of the geotechnical assessment that is quite important for geotechnical engineer to know, because you can just imagine construction works will definitely impose loads on top of the ground. So whatever that being imposed on top of the ground, it will create settlement. So that comes geotechnical engineer to check whether the settlement, the estimated settlement is below what's been set in guideline, or it's too substantial. If it's too substantial, then something needs to be proposed in order to improvise the ground. So that's how this settlement estimation is very important lah. And as what I've mentioned, any loads that being applied on top of the ground, it will induce settlements, and these settlements can be divided into two types. First is elastic immediate settlement. This elastic immediate settlement, you can just imagine if you walk at if you walk along the beach, okay, when you step your foot on the sand, you realize that your feet will settle. Okay, but it settle at certain depth. This is what we call elastic settlement or immediate settlement. Okay, the settlement that happen in one immediately, in a very fast instant. While the second settlement is consolidation. Consolidation is like is basically a settlement that is happening within fine soil, which is clay, mostly soft soil. Okay, what happened was, you can just imagine yourself a balloon. You can balloon that have been filled with water. You tie it up, and then you try to press your hands on top of the balloon, and you could see that the water within your inside the balloon will try to escape laterally. So that's what happening within clay subsoil layer. You apply the load, there will be a water dissipation trying to escape from this soft soil layer, and this dissipation, water escapes, is actually depending on time, depending on the size of the grain. I mean the size. I mean all those PSD information, the sieving that you did, you will get to know what is the percentage. So it all depends on that, and also the audiometer test lah. Yeah, so that's pretty much the consolidation settlement. And under consolidation settlement, you can divide it into two, which is primary consolidation and secondary consolidation. Secondary consolidation is something that you could see from the tilting tower in Teluk Intan, and also the tilting tower of Pisa. Okay, what happened to those two towers is that when the designer, when the contractor has completed their construction, when the tower of Pisa has been constructed, initially the designer has set up a type of foundation system to resist its load. However, underneath it, there's a wall, a soil packet, a packet of soil, soft soil, that actually still consolidating against time. And this is what we call creeping lah, secondary consolidation. And this soil pocket is actually just at one corner of the pile foundation. So that's the reason why you can see that the building is tilted and has been tourist attraction spot in Italy. And same goes to, and similar situation is actually happening at Teluk Intan. All right, so these are another settlement. The type of settlement that normally geotechnical engineer would call total settlement is the maximum amount of settlement for that one particular footprint. However, differential settlements is the difference between the 2 points of your structures. So if one point is stagnant while the other point will create a substantial settlement, then the difference between those two, we call it as the differential settlement. And JKR has set 25 mm as the allowable differential settlement for any building foundation design. All right, so this is the elastic settlement. I'm not going to talk further about this because this is pretty much something that you would learn in foundation engineering module. Okay, and these are some of the guide or guideline for settlement for settlement control. Yeah, for settlement control procedure. Okay, this is the geotechnical design criteria produced by JKR. So if somebody plan to further up their career in as a geotechnical engineer, I would hope that he would use this guideline. He would read this guideline carefully, because this is something that you will be repeating, look upon, and every time when you do your geotechnical design. All right, so last is the slope assessment. Okay, can somebody explain to me, have you guys learned anything about slope?
Yes.
All right. Okay, in fact, for your IDP, okay, like I said, if you want to if you have earthworks to be carried out at your site, so definitely you'll be having a cut and fill procedure. So, and the reason why you're having this cut and fill procedure is to actually to fill up the differences in platform level lah, design. If you're having a 2 platform level, then you're gonna have 1 split level sections, and these split level sections, unless if you're proposing a vertical structures, then you don't need to do your slope stability checking. However, if you are allowing a certain angle of slopes, you as a geotechnical engineer, you need to check what's the stability of that slope. Okay, that basically lies under this section. Okay, let me just, yeah, you can have a go through my slides later, because I hope you will explain one by one about the detail about slopes. However, I would like to stay on this slide, because this is what this is the guideline set by JKR for Malaysian case. So for any of your cut and fill, if you have slope, please adhere to this criteria, because it will be more realistic. Okay, so if you are having a cut slope, make sure that your cut slope is 1 to 1.5. No gentler than this. When I say gentler, if you set your cuts and not gentler, no steeper. Okay, when I say steeper, it means 1 to 1, 1 to 1.2. No, you cannot have a steep gradient for cut slope. At least 1.5. Okay, if you want to make it 1 to 2, by all means, that's more gentler. But of course, you're gonna lose your platform footprint lah, if you are having a gentle slope. And as for fill slope, if that's the section where you actually plan to fill up the ground, make sure the slope is at least 1 to 2, no steeper or lower than that. And if it's a cut slope, you can cut the rock slope in this gradient lah, 4 to 1. And if the slope is too high, JKR has stated that the maximum of a slope is 6 meter. And if you still require sloping procedure to be carried out underneath, then you must have this 2 meter buffer. And then you can continue with your 6 meter. And if it's still not reaching the toe, you would need to have this buffer as well. So make sure that you would have enough horizontal distance lah, if your slope is too high. Okay. All right. So I think yeah, these are the common types of slope failures. But yeah, I think we can just stop here. Okay. Yeah, before we end our session for today.
Yes.
Okay. Yang jawab tadi, can you explain what is TF, what is TM? Oh, terus senyap.
Kejap-kejap saya recap balik.
Tak apa, borak. Okay. Apa yang you tahu about FOS?
Doktor boleh ulangi sekali, saya tak dengar.
Tak, apa yang you tahu tentang FOS?
Oh, FOS. Saya cakap dalam Melayu boleh tak?
Boleh, no worries.
Oh, FOS tu macam tadi macam Azam kata lah. Kita tak boleh nak jadikan dia maksimum tu sebagai 1.0 sebab kita tak tahu apa yang akan jadi seterusnya pada masa akan datang. So kita kena buat ekstra daripada 1.0. Macam tambahlah macam kita estimate lagi tambah 1.0 lagi ke, macam jadikan dia 2 atau 3. So
based on guideline, bukannya tambah ikut suka.
Okay, based on guideline lah.
Based on guideline. We as engineer, we need to say based on fact. We cannot just simply say it.
Okay.
Okay. Yeah, betul. Yeah, I agree. Itu kita punya safety factor. The main point of having factor safety to have a safety factor for the designer. Okay. And as for slopes, okay. Thanks very much for entertaining me just now. Okay, and coming back to these slides, okay, what does it mean? FL is equals to tau F divided by tau M. Okay, tau F, okay, you understand that, okay, by just looking at this figure, okay, by looking at this, you could see that how slip failure would happen, would possibly happen for any particular slope is because of the weight of the slope itself. Okay, so it's a weight. When we talk about weight, so this weight would produce a Kn, a kilonewton, a force. Yeah, right? A force to this due to this angle. And and as for the resistance, okay, if you imagine in the foundation part 2 just now, I've mentioned that, okay, we've got a load from the structure and we've got resistance from this QS and QB. Okay, however, for slopes, this load actually comes from the body itself, which is the load, the weight of the load. And the resistance must be the shear strength, the strength of the soil. So coming back to this, okay, for slope stability analysis, this is the most important equation that you need to remember. Factor of safety is equal to TF, which is the resistance over mobilized. Okay, resistance over mobilizing. Resistance meaning the strength of the soil. Okay, so if saya nak explain in detail pun sukar sebab like I said, you need to literally understand the function of SI lah. Sebab you need to understand, okay, when we talk about stability, it relates to strength. And for strength, what kind of testing that we should carry out at site or in the lab in order to get the strength value of the soil. However, for stability analysis, the equation is just merely this, which is the tau F, the resistance over the mobilizing force. So mobilizing force is the weight of this of the material, while the resistance is the strength of the soil. So if I want to design a slope with FOS equal to 2, okay, I'm talking about FOS equal to 2. So my resistance, my TF, must be 2 times higher than my mobilizing force. All right. So from the weight. So that's the thing. When you know that your soil strength must be greater, so you need to imagine that your slope cannot consist of any soft soil lah. Because if it's a soft soil with a very steep, because as the steeper you go, the more weight you will the soil will encounter. Okay, so if it's gentler, then less weight, less what you call it, less slice distance if it's a gentle. But if it's a steep, you will have a very long slice. And this the length of the slice pretty much explains the magnitude of your weight lah, of your force lah acting. So if your slope, if your site consists of soft soil, if you are saying that you are going to cut your slope 1:1 or 1:0.5, very steep slope, okay, a very steep slopes, then it wouldn't reach FOS 2.0. Okay, so the best way is to have it gentle in order to reach that. But well, I think most of you will be a bit confused of what I'm trying to explain. But never mind. I mean, it took me a while to understand the concept as well. But just remember that FOS, we need to have a higher TF, which is represent the resistance, over M, over tau M, which is the mobilizing force. And if you think logically, in terms of mathematical attributions, if you got X equal to A over B, if you want X to be more than 1, you would need your A to be higher than your B. So that's how you relate the numerical attribution with factor safety theoretical concept. Okay, so yeah, this one is just another subtopics. If those who are interested in geotechnical engineering, once they've gone through all these parts that has been shown in my slides here, they probably could move further on reading about retaining structures, ground treatments, how you treat the ground, how KLCC was built, what kind of ground treatment was adopted when they when they constructed the foundation of KLCC. So yeah, it is one of quite interesting topics to read about in geotechnical engineering. And the third one will be the monitoring and instrumentation. And forget to add one more under geotechnical engineering, especially nowadays, tunneling engineer is in highly demand in Malaysia. So it is one of the specialized geotechnical subject. And for those who are interested, could definitely get into that sub-discipline lah in the future. All right, so I think that will be it. Dr. Aizat ada ke?
Ada.
Okay, Dr. Aizat. Yeah, pretty much there with my slides.
Right, Dr. Reza, tadi dia buka I don't know where it is now.
But thank you very much, Dr. Shazwan, for a very very complete and very useful informations and lessons for the students. They started their foundation, but most of the topics will be later on. So at the moment they just started calculations on shallow. So piling apa semua tu belum lagi lah. And then slope will be the last. So itulah the order is quite misunfortunate for them to design. So somehow they have to learn to design before learning the concept. Macam itulah.
Okay.
Alright.
Hopefully everyone tak serik. Oh, kau main buntang lagi kau apa? Siapa tu? Azam lah. And thanks very much for having conversation during ni. And please let your friend know this not the time to be passive. You guys needs to speak up. There's a lot of competition out there. Alright, so that's pretty much for myself. Zaizat.
Alright, thank you very much. Yeah, but actually the Kuwaitis they completed their foundation earlier, so shouldn't be any problem for them lah.
Yeah, hopefully.
Okay. Alright. Thank you very much, Dr. Shazwan again. Nanti I'll sort your.
Tu later lah nanti.
Itulah. Okay.
Yeah, I need to discuss with you about that next month punya Narim tu.
Tak apa, nantilah. Tu nanti.
Okay, sure. Alright. Okay.
Okay, thank you very much. So kids, tadi tak apalah ni tak ada, I didn't take the attendance, but it's okay. Alright, thank you. Assalamualaikum. Have a good weekend. Have a good day and happy. I already said happy weekend kan. Okay, take care. Okay, bye-bye.
Alright.
Thank you, Doctor. Thank you very much.
Thank you so much, Doctor.
Thank you, 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 Doctor.
Alright, thank you all. I'll leave Bye.
Hi guys, welcome to the National University of Malaysia, university that inspiring futures, nurturing possibilities. Today, I will bring you guys around UKM. Let's go!